Hello viewers, I am Kausalya. Today we are going to discuss about the problem. Find the current supplied by the source in the circuit shown in figure. Also find the power in each resistor. So here this is our given problem. So in this problem you see we are having many resistors which are connected together and there is a supply voltage of 20 volt, right? So we need to calculate the current that flows through the circuit here, and apart from that we have to calculate the power dissipated in each resistor, right? So here totally we are having how many resistors? You see 1 2 3 4 5 6 7 resistors in total. So we have to calculate the power dissipated in all these 7 resistors, right? So here the first step is I am marking the nodes as A, B, C, D so that while solving the problem, while solving this network, it will be very easy. So here you see I had taken A, B, C and D here, right? So I'll explain the current that flows through the circuit later, right? The first step is now we are going to resolve the circuit. I'm going to calculate the total resistance. Once the total resistance is calculated, here we are having a voltage source. So once V and R are known, then we can easily calculate the current that flows through this circuit, right? So here the first thing to be noticed is, you see, look at these two 1 amp resistors. So this 1 amp resistor and this 1 amp resistor, right? So now can you tell me whether these resistors are connected in series or in parallel? You see here, that is the current flowing through this resistor flows through this resistor also, right? Or the ending point of one resistor becomes the starting point of this resistor, okay, anyways. So here these two resistors are connected in series, right? So how to calculate the total resistance here? Just you have to add 1 ohm plus 1 ohm gives the value of 2 ohms here, right? So now we can replace these two resistors by a single resistor of 2 ohms. So again that resistor is connected between the points this B and D, right? Because we are combining only these two resistors. So once these two resistors are combined, then they are connected across the points B and D. Therefore, we are drawing a 2 ohm resistor like this, right? Now again you see, when you look at these two 2 ohm resistors, we can easily tell, right, whether they are connected in parallel or in series. They are connected in parallel because you see the one end of both the resistors are connected to a common node and the other end of both the resistors are connected to another common node. So these two resistors are in parallel. Now we are going to combine those two resistors. So how to calculate the value of resistors in parallel? So it is given by this formula, that is 1 by R is equal to 1 by R1 plus 1 by R2, or else you can use this one, R1 R2 divided by R1 plus R2. This formula will gives you the direct value of this resistance, right? So 1 by 2 plus 1 by 2, so that gives a value of 1 ohm. Right. So now between the points B and D, these two resistors are combined together and here we are having the value of 1 ohm resistor. Right. So again, when you look at the circuit here, you see, now look at these two resistors, this 3 ohm and this 1 ohm. Okay, again, how they are connected? Can you make a guess here? Again these two resistors are connected in series, right? Because you see the ending point of this 3 ohm resistor is D and that D becomes the starting point of this 1 ohm resistor, right? Or in other words, when you look at the current, just assume whatever may be the value of current there. So if the current flowing through this 3 ohm resistor, you see it again flows through this 1 ohm resistor because there are no more paths here to go through. Right, so these 3 ohm and 1 ohm resistors are in series. Then how to find the total resistance? Just we have to directly add these two resistors, that is 3 plus 1 here. So here the total value of resistance is 4 ohms. Now again that resistor is connected between the points B and C. You see here we had combined these two resistors, right? And again this resistor combination, it is connected to the same points C and B here. Therefore here I had drawn this 4 ohm resistance between the points B and C, right? Now again when you look at these two 4 ohm resistors, right, how they are connected? They are connected parallelly, because you see one end of both the resistors are connected to C and other end of both the resistors are connected to B here, right? So how to calculate the value when the resistors are connected in parallel? You see again the value is 2 ohms here. Here also you can directly use the formula R1 into R2 by R1 plus R2. Okay, both gives the same answer. So here there is 2 ohm resistor. Therefore, between the points B and C, we had combined these two resistors. So they are now reduced to a value of 2 ohm resistors here. Right. Now, our circuit is simplified like this, right? Again, when you look at this circuit, you see this 6 ohm and this 2 ohm resistors are connected in series, right? Now, how to calculate the total resistance? You have to simply add the values. So, 6 plus 2 will give you the answer of 8 ohms here, right? So, our circuit gets modified like this. You see here we are having a 20 volt, across 20 volt there is 6 ohm, and again when you combine this 6 ohm and 2 ohm there is a total resistance of 8 ohms here, right? So this is our final simplified circuit. Again you see this 8 ohm and 6 ohm, they are connected across a 20 voltage source. Now we can easily calculate the value of currents that flows through this 6 ohm and this 8 ohm, right? So here you see by Ohm's law, here let I1 is the current that flows through 6 ohms. Therefore I1 is V by R 20 by 6, that is 3.33, right? Again when you consider I2, it is again a V by R, therefore 20 divided by 8, so that gives the answer of 2.5 amps here. So now we can easily calculate the total current here, right? It is I1 plus I2. So here I1 plus I2 is given as 5.83 amps here, right? So the first part of the problem gets over here. We had calculated the current that flows through the circuit, right? Next is we are going to calculate the power that is dissipated in each resistors. So first we start with power dissipated in this 6 ohm resistor, right? So what is the formula to calculate the power dissipation? It is nothing but I square R, right? Since we know the value of I, we can use that formula, that is I square R here. Therefore, so I square R, you see this is the value of I and this is your R. Therefore, the power dissipated is 66.53 watts here, right? Now, we have to again look back at our diagram. So, always keep in mind while calculating the power dissipated in each resistor, you have to calculate the power dissipation in the resistor which is present in the problem, that is which is given in the problem, not by the resistor we have reduced, right? Totally we have seen around 7 resistors, right? I hope so. So we have to calculate the power dissipated in all those 7 resistors, okay, not the combination of resistors. So always keep this in mind, right? You see, randomly we will do this mistake, that is initially we will calculate the power dissipated in 6 ohm and then we will move to power dissipated in 8 ohm, but 8 ohm resistor is not given in the problem. 8 ohm is nothing but it is, we have reduced the resistors, okay, that gives value of 8 ohm. So once this 6 ohm is calculated, we will do that mistake, okay? So always keep in mind, you should calculate the power dissipated in the resistor which is given in the main circuit, okay, that is the initial circuit or that resistors present in the problem. Okay, keep that in mind. So again when you move here, you see again this 6 ohm resistor is given in the problem and we know the current that flows through this 6 ohm, that is this 8 ohm is nothing but this 6 ohm and 2 ohm, right? So the current flowing through this 6 ohm resistor is I2, We know the value of I2. Therefore, now calculate the power dissipated in this 6 ohm resistor here. Therefore, you see, power dissipated in another 6 ohm resistor is I2 square into R. We know the value of I2. So, just substitute and the final value is calculated as 37.5 watts. Right. Now, again, look back at this circuit. Right. We know the value of I2, right? This I2 flows and reaches the point C. At point C, it gets divided into two. Right. One as I3 and another one as I4. Right. So what is the value of I2? So I2 is nothing but 2.5 amps here. So this current gets divided into 2. And again, the main thing to be noted is, you see here, both the value of resistors are equal to 4 ohms. Right. The resistors are of 4 ohms. So can you guess how the current will get divided? The current will get divided equally because here the resistor values are same. If they different, then depending upon their value, there will be intake of current. For example, if you have low value of resistance, then the value of current will be high. In case if you have high value of resistance, the current will be low. Right. But here, since the value of resistors are same, the current gets equally divided in these two branches. That is 2.5 by 2 is the value of current that flows through this 4 ohm resistor as well as through this 4 ohm resistor. So this is what written here. Okay, current flowing through 4 ohm resistors are 2.5 by 2, which is equal to 1.25 amps. Right. Now look at this circuit. Right. So here we are having that is, just a minute. You see here, the current flowing through this 6 ohm is 2.5 and this 2.5 gets divided into 1.25 and 1.25. Right. So, you see again this same thing. Right. This 2.5 gets divided as 1.25 and 1.25. But this CB, you see, how come this 4 ohm resistance here? This 4 ohm resistance is nothing but it is the series combination of 3 ohm and 1 ohm. Right. So now we can easily calculate the power dissipated in this 4 ohm resistor, right? Because this 4 ohm resistor is present in the problem. So again use the formula I square R, that is 1.25 whole square divided by 1.25 whole square into 4 gives the value of power dissipated in this 4 ohm resistor. So the power dissipated in the 4 ohm resistor is given by 1.25 square into 4, which is nothing but 6.25. Right. Again, when you look back at the diagram, you see the current flowing through this CD part is again 1.25. Right. Therefore, the current flowing through this 3 ohm is 1.25 and this 3 ohm is present in the problem. Therefore, now calculate the power dissipated in this 3 ohm. Again, it is 1.25 square into 3. So here it is 1.25 whole square into 3, that is 4.6875 watts here. Right. Again look back at the diagram. The current flowing through this 3 ohm resistor is 1.25. Right. So now when you proceed gradually upwards, you see here, that is at this junction D. Okay. Here D, we are having a combination of two 2 ohm resistors, right? Therefore, what happens here? This current 1.25 reaches this point D, and again here the value of resistors are same. Therefore, the current gets equally divided. That is 1.25 divided by 2 amps flows here, and again 1.25 divided by 2 amps flows in this resistor, right? Therefore, the current through 2 ohm resistor is 0.625 amps here. Right. So, current flowing through this 2 ohm is again 0.625 amps. Therefore, we can easily calculate the power dissipated in this resistor, right? It is 0.625 whole square into 2. So, therefore, that gives the answer of 0.781 watts here. Right. And now, so again when you look at this diagram, that is this is our original diagram which is given in the problem, right? You see here flows 0.625 and again here also 0.625 current flows, right? So since these two resistors are connected in series, the same current flows through this resistor also, right? Therefore, how to calculate the power dissipated? It is again 0.625 whole square into 1 and here again 0.625 whole square into 1, right? Therefore, the power dissipated in 1 ohm resistor is, it is 0.391 watts here, right? So finally, we have just made a tabulation of power dissipated in each resistors. That's it, right? So totally 2, 4, 6, yeah, 7 resistors here, and we had individually written the answers, that is the power dissipated in 1 ohm resistor, 2 ohm, 3 ohm, 4 ohm, like that, right? And here the totally the power dissipated is 116.53 watts. Now we can easily cross check whether the value is right or wrong. So how to do that? The thing is, you see, you can directly use this formula V into I, right? We know the value of voltage as 20 and we know the value of total current as 5.83, right? Or else you can use this formula, that is V square by R, right? We know the value of V. We know we should calculate the value of total resistance R. So again, when you look back at the circuit here, so this is our final simplified circuit, right? So here two resistors are in parallel. So just calculate the equivalent resistance. So this is what done here. So total R is calculated. Now just substitute in this formula and again the value of power is 116.53. Right. So now this tallies with the tabulated value. So here comes the end of this problem. If you have any doubt, let me know in the comment section. The problem seems to be little bit bigger, but once you understand the concept, then it is very easy. So if you have any doubt, let me know, right? Thank you.